All right, so before Christmas break, we covered how to find the vertex, the directrix, the focus, and how to graph parabolas. We also learned how to write an equation in standard form given a piece of the graph, whether it was the vertex and a focus, the vertex and the directrix, and we were able to write equations. So today we're just going to review that information. So when your p-value is positive, we know that it's a happy parabola when it's an x squared, and it's a U shape and it's smiling. When the p-value is negative, it's an upside down U. It looks like a frown. So it's a negative number. A negative person would frown. Then when your graph opens left and right, when your p-value is positive, it's a letter C. When your p-value is negative, it would be the backwards C. So we're going to actually focus on some examples in today's review where the vertex is not at the origin. I think I did give you some in the homework where the vertex is at the origin, so it does make it a little bit simpler. So again, all of this is just a review of what we covered before Christmas. If you've forgotten any of these skills, I highly recommend you go back through, rewatch the YouTube videos, and start getting ready for Friday's quiz. So let's go ahead and look at our first example. Now, this one is actually got a vertex that is not at the origin. So again, let me add a little bit here to the top of this slide, and I'm going to show you the standard form that we're going to be filling in, or working with rather. So for this one, this given equation is in standard form, and it's the standard form where it's x minus h squared equals 4p y minus k. Remember the h value is always with the x and the k is always with y. Remember this hk is the vertex. And when you go to pull it out of the standard form equation, it's backwards of what you would think. Now, when it's an x squared, and your 4p value is positive, your graph is going to look like the letter U. When it's an x squared and 4p is negative, it'll look like an upside down U. When the equation has y minus k and the y is squared, this is going to be the C and the backwards C. So when 4p is positive and it's y minus k squared, then it's the letter C. When 4p is negative and it's the y squared, it'll be the backwards C. So for this first example, notice it's got the x squared. So x squared minus h squared, x minus h squared equals 4p y minus k. So this is my h, this negative 16 is my 4p, and the positive 5, or it's actually backwards, that's going to be the k value. So again, when you pull out the h and the k, it's backwards of what you would think. So my vertex is located, again, hk. My h is positive 2, my k is negative 5. Pretty good so far? So that's what we found the first part. Now we're going to find the focus. To find the focus, we need to find the p-value first. Remember, the p-value is how far away the focus is from the vertex, and it's also the distance between the vertex and the directrix. So this is why we need to find that p-value, because it's going to help us find the focus and our directrix. So again, 4p, I'm going to set that equal to the negative 16. It's this piece right here. So I can divide both sides by 4. And P equals -4. Now, the negative sign indicates that this is going to be the reflection. And my focus is going to be 4 spaces away from that vertex. So what I can do here is, in order to find the focus, I am going to take the p-value and I am going to add it to the non-squared variable from the beginning, which is the y. So I take my vertex, the 2, -5, and I'm going to take the p-value that I just found, and I'm going to add it to the y. So it's the variable from the beginning that wasn't squared. So my focus point is the ordered pair 2, -9. I'm adding -5 plus -4, and that gives me my focus point. For the directrix, we add the opposite of P. So for the directrix, again, it's the non-squared variable, so it's y equals, and the y equals -5, but now I add the opposite of P, which is +4. So my directrix is located at y equals -1. Remember, it's an equation. The next thing I'm going to find is my y-intercept, because I have to graph this now. Now, I've actually answered the 3 questions. I found the vertex, I found the focus, and I found the directrix. But it's also asking me to graph it. So just by finding these points, it's not enough to get a nice U shape. So it'll be beneficial to find the y-intercept. Remember, to find a y-intercept, we plug in x equals 0. So I go back to my original, and I'm going to plug in 0 for x. I'm going to simplify everything down here. So 0 minus 2 is -2. I'm going to distribute the -16. And that should have just been a 5, not a 15. I'm going to square the -2. And then I'm going to move the 80. I'm going to add it to both sides. I get 84 equals -16y. Divide by -16. I could simplify this, divide them both by 4. But I'm going to graph this, so I'm actually going to make it a decimal, and it's -5.25. So my y-intercept as an ordered pair is 0, -5.25. You could also key it in WebAssign like this, either way. So now let's go ahead and get all this information onto our coordinate plane. Let's graph it. So I'm going to graph my vertex first. My vertex is 2, -5. I can also graph my focus, and that's at 2, -9. I can also graph my directrix. Now, remember when we did this a long time ago, we also found the axis of symmetry. So I already can see that my parabola is going to be going down. Here's my imaginary line of symmetry. I'm going to use this to get another point, but I'm going to graph my y-intercept. It's over here at 0, negative 5.25. That's the y-intercept. And the reason why I drew in that red imaginary line is because I need to use that to get another point. So right now, I've got this side of my parabola. To get the right side, notice how it's 2 spaces away from that imaginary axis of symmetry line. So I could go 2 spaces over here and put another point. And now I can complete my parabola. Remember, the focus is always inside the parabola, and the directrix is always along the back. And this was the focus. So notice this time it's got the y is squared. So this is the y. Let me change the color. Remember, k is always with the y. H is always with the x. So again, if I want to pull out my vertex, it's backwards of what you would think. So it's 6, negative 1. Again, remember it's h and k. To find the value of p, remember this right here is 4p. So 4p equals 1/2. You can either divide both sides by 4, which is really multiplied by the reciprocal. You could also turn this into a proportion, do cross products. However you want to solve for p. P equals 1/8. Again, p is how far away the focus is from the vertex and how far away is the directrix from the vertex. So in order to find the focus, I'm going to add p, this time to the x of the vertex, because that's my non-squared variable. So here's my vertex. This time I'm going to add and subtract p, or I'm actually just going to add p, add p to the x of the vertex. So my focus point is at 6 1/8, negative 1. For the directrix, you're going to subtract p to that x. So 6 minus 1/8. I'm going to change the 6 into 5 and 8 over 8. So I can subtract that fraction. So my directrix is 5 7/8. So now I've answered the 3 questions. Again, I need to find another additional point, and then I can use my axis of symmetry. Now, this particular graph is not going to touch the y-axis, so I'm not going to find a y-intercept. I'm going to find the x-intercept. So again, notice how all the work we did for the focus and the directrix was adding the p to the x. I'm also going to find my x-intercept. It's the non-squared variable. So to find your x-intercept, you're going to set y equal to 0. So I'm going to do 0 plus 1 squared equals 1/2 x minus 6. 0 plus 1 is 1. I'm going to distribute the half. going to square that. Now, if you want to multiply everything by 2, you can do that to get rid of the fraction, or you can work with it. I'm dividing both sides by 1/2, which is really the same as multiply both sides by the reciprocal, which is 2. So 8 equals x. So my x-intercept is the order pair 8, 0. Now let's graph all of this. So I'm going to go ahead and graph the vertex first. And that's the order pair 6, -1. It's right here. It's the vertex. I can also graph my directrix. Now my directrix is going to be super close to the vertex because remember your directrix was x equals 5 7/8. So it's really close here behind it. Your focus point is inside the parabola. It's surrounded, so it's 6 1/8. So you got a focus that's right here. You've got your y-intercept, which was 8, 0. That's the x-intercept. Now, again, we're going to use our line of symmetry here. So here we go. It goes through the vertex. So far, I've got this part of my C going on. I can use the line of symmetry. See how it's one space away here, this x-intercept? So I could go one space down here, and I can have another point right here to get the other half of my C. And there's your graph. So when we did this before, we were able to write equations in standard form given pieces of our parabola. Now, when I'm given pieces of the parabola, to know which standard form I'm going to use, I always like to give myself a rough sketch. I'm not going to expect you to graph given information like this. What you're going to need to do is give yourself a rough sketch so you'll know, is it a C, is it a backward C, a U, or an upside down U? So let me go ahead and graph my vertex. -1, +3. And then I'm also going to graph the directrix, which is y equals 6. Remember, the directrix is always behind the vertex. So I can already see that my graph is going to look like this. I don't care where it's hitting the y-axis or where it's hitting the x-axis. I'm just doing the rough sketch so that I know that I'm using the x minus h squared. And because it's an upside down U, I know my 4p value is negative. So this is going to be the standard form I'm filling in. I already know my h and k. That comes from my vertex. So all I need to do is find the p-value and then times it by -4. And the p-value again is how far away is that vertex from the directrix. And you can see, since I gave myself a nice little sketch here, you can see that it's 1, 2, 3 spaces away. So my p-value is 3. So now we can go ahead and plug everything in. I guess I can do it right here. So my h is -1. So x minus -1. My p-value is 3. And then my k value is positive 3. All I need to do is simplify this negative negative and make it x plus 1 squared, and then also multiply the negative 4 and the positive 3. Negative 12 y minus 3. And you're done. And there's your standard form. All right, so your ellipses are your conics that take on an oval shape. And you can either have your ellipsis with a major axis horizontally or vertically. Remember the numerators, we kept them the same. So the x minus h squared is always going to be the top of the first fraction. And then the y minus k squared will be the top of the second fraction. What's going to move is the a squared and the b squared. Remember, a squared is always the bigger number. And wherever the bigger number is, that's the location of your major axis. We also need to find the c value. The c value can be found by using this equation of a squared minus b squared. We're going to be using the value of a. The value of a is how far away is the vertex from the center. The b value is how far away are the covertices from the center. And the c value is how far away the focus points are from the center. So let's go ahead and try an example. So again, we want to find the center, the vertices, the covertices, the foci, and we're going to graph it. So again, in my equation, this is h, this is k. The bigger number in the denominator is going to be my a squared. So my a squared is 25. The smaller number is my b squared. So from the equation, my h and k is now my center, not my vertice. So my center is located at -2, +1. It's backwards of what you would think. The center is the hk now. Now I need to find the value of a. The way that I find the value of a is I square root both sides, and I get a is equal to plus and minus 5. B is equal to plus and minus 2. To find C, I'm going to use the equation c squared equals a squared minus b squared. A squared 25, b squared 4, subtract, square root. Now, I use the A to find the vertices. I'm going to use the B to find the covertices. And I'm going to use C to find the focus points or the foci. Now, remember, the endpoints of the major axis are your vertices. The endpoints of the minor axis are going to be the covertices. So again, you saw that the major axis was the y. It's vertical because the 25 is the bigger number, and the bigger number is under the major axis. So what I'm going to do is take my center point, the -2, +1, and I need to add and subtract the 5 to the y of the center point, because that's my major axis. So I'm going to be adding and subtracting 5 to the y of the center, because that's my major. Vertices are the endpoints of the major. So it becomes -2, -4. So 1 minus 5, and then 1 plus 5. These are the vertices. For the covertices, they're the endpoints of the minor axis. The minor axis is the x-axis. So again, you're going to take your center point, but now you're going to add and subtract the b value to the x. So this becomes -4, 1 and 0, 1. These are the covertices. The focus points are always on the major axis. So we're going to take now the c value and it gets added to the y because my major axis is the y-axis. So I'm going to take the center and add and subtract the c value to the y. So 2, 1 minus root 21 and -2, 1 plus root 21. Just leave it in simplest radical form. Now, for graphing purposes, we can go ahead and approximate the square root of 21. So the square root of 21, when I do it on my calculator, I end up getting 4.58. So I'm going to round this to 4.6. So what I'm going to do is this one approximated is going to be the order pair -2. And when I do 1 minus 4.6, I get -3.6. And then when I do 1 plus 4.6, I get +5.6. So now I'm going to go back and I'm going to graph all 7 order pairs, the 2 foci, the 2 covertices, the vertices, and the center point. Then I'll connect it and make my oval shape, my ellipse. So let's go ahead and graph the 7 points. Again, let's do the center first. It's the order. I have vertices located at -2, +6. There's a vertice. And then -2, -4, and then I have the covertices located at -4, +1. It's a covertice. And then another one at 0, 1. Now I can go ahead and connect the red and blue. Don't make it like straight lines. It's got to have a curve to it. It's got to be like an oval shape. So there's your ellipse. I also have to add in the focus points. And remember, we approximated those. So -2, and then 1, 2, 3, -3.6. So that's a focus. That was the -2, 1 minus root 21. And then the other one is up here at 5.6. 2, 3, 4, 5. So really close. So -2, 1 plus root 21. And that's your other focus. And there's your ellipse. One last example. We're actually going to write an equation given some information. Again, I didn't give you a coordinate plane here, but I'm going to give myself a quick little visual so I can see where my major axis is going to be located, if it's going to be horizontal or vertical. So let me go ahead and graph these vertices. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You're not asked to graph it, but I like to give myself a visual so I can see what I'm dealing with. So I have vertices at positive 5, 2 and negative 5, 2. And then I have my focus points or foci at positive 3, 2 and negative 3, 2. Remember, the focus points are always on the major axis. So I can see already that my major axis is horizontal. These are all on a straight horizontal line. So again, you can start to set up. Remember that x minus h is always on the top of the first fraction, and the y minus k squared is always on the top of the second. Again, remember what's moving is the a squared b squared. Again, since it's a horizontal line, my bigger number is going to be underneath the x squared. So now I need to find a and b in order to do this. Now, remember that the value of a is how far away is the vertex from the center. The value of b is how far away is the co-vertices. And the value of c is how far away is the focus from the center. Well, I don't have any co-vertices here, but I do have a focus and I do have a vertices. I need to find the center point. Remember, the center is going to be the midpoint of either the vertices or the focus points. Let me just go ahead and calculate the midpoint between the two vertices. I add the x's, so negative 5 plus 5, divide by 2, and then add the y's. 2 plus 2. This gives me 0 over 2, 4 over 2. So it gives me the ordered pair 0, 2. So this is my center. So my center is located right here. The reason why I want to find the center is I need to know how many spaces away is the focus from it and how many spaces away is a vertex from it. So for the focus, you can see that it's going to be 3 spaces away. So my C value is 3. From the center to the blue, it's 5 spaces, and that's your A value. What I need to fill in is A squared and B squared. Well, I got A squared. All I have to do is take this A equals 5, square it, and A squared equals 25. But to find B squared, I need to use this formula. Because I have C squared, it's 9, but I don't know anything about co-vertices or minor axis length, so I got to use the formula. So 9 equals 25 minus B squared, subtract 25. Negative 16 equals negative B squared. Divide by negative 1. 16 equals B squared. I don't need to square root it because remember, all we're doing is filling it in down here. And then I'm going to fill in the A squared. Remember, your center down here, this is your H and K. So let's fill it in. So x minus 0 squared. My major axis, the A squared is 25. Y minus 2 squared. My B value is 16. And it equals 1. I'm going to go ahead and simplify that x minus 0 and just make it x squared over 25. And you're done. And there's your standard form.